Hi and welcome to this session on Mathematics, Chapter 1 Real Numbers for Grade 10. We shall be covering Section 1.4 Revisiting Irrational Numbers, Examples 10 and 11. Before we go ahead, remember that the sum or difference of a rational and an irrational number is always irrational. That is, a rational number plus or minus the irrational number will give us an irrational number. As an example, 5 minus square root of 3 is an irrational number. The second fact to keep in mind is this, that the product and a quotient of a non-zero rational and an irrational number is irrational. That is, a rational number multiplied by or divided by an irrational number gives us irrational number. As an example, 3 multiplied by square root of 2 is an irrational number. Now let's solve example number 10, which says show that 5 minus square root of 3 is an irrational number. Now let us assume the opposite. Let us assume that 5 minus square root of 3 is a rational number. Now if it is a rational number, then we can find co-prime numbers a and b where b is not equal to 0, and we can write this rational number as 5 minus 3 square root of 3 is equal to a divided by b. And if we rearrange this equation, we get square root of 3 is equal to 5 minus a divided by b. Now we see that both a and b are integers, and the right hand side, that is this side, 5 minus a by b, is therefore a rational number because all the numbers in this side, that is 5 or a or b, they are all rational numbers. Therefore we can say that the right hand side of this equation number 1 is a rational number. So if the right hand side of an equation of the equation 1 is a rational number, then its left hand side, that is square root of 3, should also be a rational number, because if it is not, then the equality will not hold, because rational number on one side cannot be equal to irrational number on the other side. Therefore, if the right hand side is a rational number, then the left hand side, that is square root of 3, will have to be a rational number as well. Now this, let's call this as equation number 2, and this equation 2 actually contradicts the fact that 3 under root of 3 is an irrational number. Now we know that square root of 3 is an irrational number by our general information and by the definition of an irrational number. We know that square root of 3 is an irrational. Therefore, when we see that square root of 3 being called as rational in equation 2, this leads us to a contradiction. And we say that this contradiction has appeared because of our initial assumption, which was that 5 minus square root of 3 is a rational number. Hence, we can conclude that 5 minus square root of 3 is an irrational number. Similarly, we can solve example number 11, which says that show that 3 times square root of 2 is an irrational number. So let's start by assuming the opposite, and let's say 3 times square root of 2 is a rational number. If this is a rational number, then we can find co-prime numbers a and b where b is not equal to 0, so that 3 times square root of 2 is equal to a divided by b. Now let's rearrange this equation as square root of 2 is equal to a divided by 3b, and let's call this as equation number 1. Now if we see the right hand side of this equation 1, we see numbers a, we see number 3, we see number b, and all these three numbers, that is 3, a and b, are integers. Therefore the right hand side of this equation 1 will be a rational number, because all these three numbers, 3a, b and number a, number b and number 3, are integers. Therefore, right hand side is a rational number. Now, if the right hand side of an equation which is true is rational, then its left hand side should also be a rational number. That is, square root of 2 should be equal to a rational number, and let's call it as equation number 2. Now, equation 2 contradicts with the general known fact that square root of 2 is an irrational number. So we can say that this contradiction, that is square root 2 is an irrational number and here it is coming out to be as square root of 2 as a rational number, this contradiction has appeared because of our initial assumption that 3 times square root of 2 is a rational number. Hence, we can conclude that 3 times square root of 2 is an irrational number.